intelligence is like this, straw, which the modern probe will use to suck up the water, instead of putting stones one by one and waiting for a long time. Certainly, it's not a magic bullet, it's not a magic wand which will solve all these problems, and it has, and as its backbone, lot of mathematics, lot of statistics, etc. etc. So any one of you who wish to develop a real career, this is where we start now. A real career in machine learning, artificial intelligence, quantum computing, Internet of Things, all these nice sounding paradigms must have a very good understanding of linear algebra and calculus, without which it is impossible. I mean, if you think that we will discuss Stack Exchange or certain Python coding websites, Khan Academy's videos or YouTube videos of different people explaining snippets of Python code, etc., you are completely on the wrong foot. You have to have very important, profound understanding of linear algebra and calculus. All the other things are very, very volatile. Python skills anyone can acquire, but a deeper understanding in mathematics needs lots of efforts to acquire. And that is what you need to develop a really rewarding career in artificial intelligence. So let's say artificial intelligence is a young science, only 50 years of age. It has several application areas, some of which you can see here. And when it started, as I told, I used to say all the AI systems just pretend to be intelligent. When it started, it was just search-based AI. How many of you are from computer science background? I forgot to ask this. Oh, not all. Okay. So I will try to explain certain concepts at layman's level. In 1991, this time, a chess playing program by IBM became extremely popular, and it was hitting the headlines of all leading dailies. Its name was the Deep Blue. Have you heard of this term, the Deep Blue? It allegedly outperformed Gary Kasparov, the then grandmaster of chess. Okay? Here's a set of three matches. Later Kasparov fight some cases, the way it goes on. This Deep Blue was a perfect example of search-based classical AI, which have now taken the back seats, like most of you. Front seats are captured by machine learning, large language models, etc. So this search-based AI, what it was doing, it has a huge memory, and against each move given by Kasparov on the chess agents on the board, it could very quickly search a befitting move to that, and there are some mathematical statistical functions based on which it can detect how good that move is. So it was searching following some criteria and retrieving the best moves. This way, it went on playing a nice strategy and defeating the opponent just through huge fast search technique. There was no learning. Then gradually, the search-based AI reigned over the entire research terrain of the whole globe for quite considerable number of years. And then gradually people started to come up with learning-based AI, because learning is something which is so inherent in living beings like human beings and many other creatures. So learning, when the learning-based AI came, this is the evolution of AI. In 1950s, we had the search-based classical symbolic AI. Gradually, since 1980s, came machine learning, then came deep learning, and now deep learning is also going towards the shorter and more profound, more effective realm of large language models. This is the evolution. Now, what is machine learning? What is a learning system? What is a learning system? If you set aside, this is not a question for educationists. If we set aside all philosophies, a learning system is a system which can take appropriate future decision based on past experience. And more experience comes, this capability of taking the appropriate future decision also improves. That is what a learning system does. Right? So, definitely, when one day I go on to road with my mother. I believe all of you have passed through this experience. I just try to tell what is this machine learning and how it evolves into large language models and so on. Then I go to the second part of my talk. I will put a hard stop at up to what time I have? 3? Yeah, I will have to put a hard stop at 3. So I believe all of you have gone through this experience. My mother used to point her finger to a kid's picture book and say, look, this is a cat, this is a rat, this is a donkey, this is a monkey, and so on. After a few rounds of such training, on one day when I am going on the road with my mother and the little creature passes by me wagging its tail, I would yell out, oh, look, that's a dog. I was pretty excited. What did I do? Based on those pointing into those pictures and adding a tag like this is a dog, based on that training given to me by my mother, I took a decision about the category of the creature which was by me. Such decision making happens every now and then in our life. Decision about category of something. Do you get my point? Although that creature was not the exact one printed in my book, but somehow its gross shape, size, texture, color, etc. matched. I had an inherent pattern matching with something stored in my brain. It matched, and I took a decision about its category. This is learning. And also, there is another very important, criteria in learning, that with more and more such experience flowing into you, your capability of making finer decisions would also improve. So when I was a kid of 11, 12 years of age, I used to listen to many Bollywood film songs, playback songs. I could not distinguish between female playback singers' voice. So, but Lata Mangeshkarji's name was very popular in our household, so I listened to some very interesting song and oh look, Lataji is singing, Lata Mangeshkar is singing. After 3-4 more years passed, I was 16, I could clearly distinguish, because by that time I have listened to many more songs. Lata Mangeshkar, Sunevi Chauhan, Shreya Ghoshal, Asha Bhosle, Kavita Krishnamurthy and so on. But this knowledge is not directly transferable. If you ask me, I ask you, write 5 sentences about what is the distinction between Lata Mangeshkarji's voice and Asha Bhosleji's voice, nobody can do that. Only a voice spectrum analyzer will be required, right? So now computers are very good at doing repetitive calculations. It can multiply 2 10-digit numbers in the wink of an eye, but can we impose, can we incorporate this human-level learning into the computers? Can we make them take human-like decisions, not always based on precise mathematical calculations, but based on imprecise, approximate reasoning, pattern matching, recognition based on certain higher level abstract features and so on. This is where comes machine learning. Okay? So machine learning is all about incorporating such things inside a computer, making a computer doing all these human-like decision-making things. And it's quite, so this is the definition. I won't ask you to read all those things, but this is it. And this is the very basic difference between traditional programming and machine learning. In traditional programming, you give the computer some data. The data could be unsorted lists of integers. You give the computer a program. What is a program? It's an algorithm translated into the language of computer, like Java, C, C++, etc. Now I would say these are older languages, classical, older, conventional languages of computer. Nowadays, with the advent of large language models, computers should understand our own language. Anyway, so you have an algorithm. It's a stepwise set of instructions following which you solve a particular problem. You convert this algorithm into a computer-specific language. That becomes a program. You give that program, the computer, just like a clerical person with no intelligence at all, the computer executes these programs. A very, very obedient person who will execute all these instructions on the data and give you some output. So the algorithm could be a sorting algorithm, right? So it will give you some output. And in machine learning, we expect we will give some data to the computer, and we will also give some example outputs, like what we want to do with the data, and let the computer discover how to convert, how to translate this data into this output. So I give the computer some unsorted lists of integers, I also give the computer the corresponding sorted lists of integers. I specify certain constraints like you must consume least amount of arithmetic computations, you must not consume a large memory space and so on. And I expect the computer to write down the sorting program for me. I expect the computer to solve its own problems, right? This is very much realistic now in the realm of automated program synthesis. The tasks which have been so coveted in the realm of theoretical computer science, like multiplication of two matrices and so on, they have been rediscovered with more intricate algorithms automatically by machine learning systems, which include, of course, neural networks. So there are lots of daily life usage and examples of machine learning, like in virtual assistant, traffic prediction, search engine optimization, email spam filtering, all of you have seen, recommender systems. You buy something and a lot of other things are advertised below the site page. With the increased usage of web, www, the amount of training data for modern industry-level machine learning systems have been increasing to something beyond our imagination, to those steps. Now the question of, so the machine learning system is based on data. What is data? Can I ask you this question? And one of you have been hearing the term data like anything, a lot of times. And you must have heard the cliche quote, data is the new oil. Have you heard of this? You become very old. Yes. What is data?
Actually, data is a set of values which give us a particular information about something.
Set of values which will give us particular information about something. May not, all data may not give you some information. Information is a very costly thing, right? Sit down, just relax. Anything else, please?
Data is a fact that can be measured.
Data is a fact that can be measured. All data may not be facts.
So, but some data which is not
okay.
with the...
Yeah, since the time is very limited, sit down, you are close. I will just say it like this. Anything and everything around us, anything, which you can abstractly represent, store, process, retrieve by a digital computer, by expressing it in terms of certain numbers sitting together, qualify as data. Anything which you can abstractly represent to a computer in terms of certain numbers sitting together qualifies as a piece of data to a computer scientist, not to a developer, to a computer scientist. So when I go to a bank, ask for a loan, a file opens up in my name, I become a piece of data. Okay? And I start being specified in terms of my fixed deposit amount, my CIBIL score, my credit rating, and blah, 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 blah stuff. So I become a piece of data. We have all pieces of data in our database. Every one of you have Aadhaar card, I guess, by now. Really? So, on the other hand, to a statistician, to a common person, everything comes from God or nature. To a statistician, everything results by sampling an underlying stochastic process or random process. So they think there is a random stochastic process, and every instantiation of that random process, you take a camera snapshot of that random process, you get a piece of data. The samples you get from an inherent underlying random process qualify as a piece of data. This assumption is fundamental to the currently dominating generative artificial intelligence, that everything comes from an underlying stochastic process or random process, which is governed by some random numbers. These random numbers are governed by some probability distributions. Okay, that's data to a statistician. So when we have huge range of data, I don't know why this has been frozen. Let's try again. Let's try manually. Yeah, what's going on? So I talked about all these things. So everywhere we see machine learning applications which are feeding on huge amount of training data all around us, like the recommender systems, vehicle detection, classification, self-driving cars, spam classification. How many of you have heard of Tesla 4.0? Or Tesla? Many of you, right? This transition from a completely autonomous, manual vehicle to a completely autonomous vehicle is a gradual transition. It's not a sudden one. So when we talk about cars which have lots of digital cameras, here it's not water potential, we probably see the world before then following call. How did I read the end of slideshow? Can I just go back? Yeah. So this is the way the camera of a self-driving car sees. It captures different objects before the world ahead of it. It takes frames from that world, and then it categorizes each of these objects into which one is a car, which one is a light post, which one is a pedestrian, and so on. Or it can create heat maps like this also. So we have data. One of the most, widely popular tasks in machine learning is you have different objects which are abstractly represented in terms of certain numbers sitting together. It could be just one single scalar like temperature of this room. It could be a vector. It's like an iris flower, iris flower is the example of the earliest documented collected set of data. Every flower which was an object was converted into certain measurements. Yeah, so I can show it here. You have this iris data set. I told you abstraction is the main keyword in data, formation of data from physical object. An iris flower is a physical object. In 1890s, Ronald Fisher, another pioneer of statistics in the Western world, like Professor Malala Vishwan here. So Ronald Fisher and his team gathered the iris flower data. They represented each flower in terms of 4 measurements. That time computer was not known, but they knew somehow this abstraction is going to be there for a long time. So they took the length and width measurement of this apple and petal and represented each flower in terms of these 4 numbers. So this vector of 4 components, usually vectors in physics has 3 components, in linear algebra they can have n components. So we have 4 component vectors. These vectors are representing each flower. Like the PVT vector, pressure, volume, temperature vector represents the condition of a gas, state of a gas in thermodynamics. Similarly, you could have certain numbers sitting together in the form of a matrix. Images, grayscale images are matrices. And when we talk about color images, you have red, green, blue, 3 primary color gray level images in a stack. We have, it's like a book, 3 pages, each page is a 2D array or 2D matrix. This stack version of 3 matrices is called a tensor. Okay? It's not the exact tensor you read in physics, but it's the common tensor we call in deep learning. Anyway, so this is how the data comes, and the data is actually represented. There are 3 most important facets in machine learning: unsupervised, supervised, and reinforcement. Supervised, in case of supervised learning, we need a teacher or supervisor, like the mother who told me that this is a cat, this is a dog, etc. Similarly, during the COVID time, I was working with a project called COVID reduction from GST, and we gathered the long chest X-ray images of about 3,000 patients. It was a hell lot of bad task because gathering the medical data is very tough in our country. So, but this was 2021, February, March, that time. Do you remember that time? Death rates were picking up, okay? And wet test laboratories, wet test means they will actually take your sputum sample, go in the lab and do chemical testing. That took 3 to 4 days time for every person. Lung X-ray image, if you take the chest X-ray image, you can suppress the reads from the chest X-ray, get the lungs. Inside the lungs, especially the senior people who were admitted in hospitals, and hospitals were just flooding with patients. From their lungs, you can look at the fibrosis pattern, which is the white milkish pattern on the lung. Based on the fibrosis pattern, some good doctors we hired, we contacted and they helped us. They, with their clinical eye, by looking at that fibrosis pattern, they actually put each of the lung images into 3 categories, 4 categories. Bacterial pneumonia, viral pneumonia, which is COVID, tuberculosis, which has 10,000 classes inside it, versus normal, benign, something else has happened, can go home. So now, based on the doctor is very easy. So the doctor is labeling only 1,000 such images. into these four categories. We feed these images and their labels provided by the doctor in the computer, and we wish the computer to gradually evolve and train a machine learning system which would accept the lung X-ray image, chest X-ray image, CXR, of any new patient, and based on how the doctor does it, how the fibrosis patterns for a particular class should look like, the machine should understand and summarize that in a very complicated mathematical way and apply those things onto the new image to take an initial decision and diagnosis on that new image, whether it should go to COVID, bacteria, or tuberculosis or benign. This task, where a human expert's knowledge is translated in the machine in the form of example images labeled by that person, which we also call training image, is called supervised learning. Okay? Indian banking sector loses huge amount of money every year for fraudulent transactions. Okay? So we did something for the National Payment Corporation of India, NPCI. They hired us for a project where the task was, I didn't know that before working in this project, that whenever I transact some money using GPay or RuPay, that transaction becomes a 62-dimensional vector. Like you have the 4-dimensional iris flower vector, it becomes a 62-dimensional vector, which gets stored in the server of NPCI. And in that vector, there is from which ATM I am doing it, who am I, how old is my account, from which merchant I have purchased what product, everything is there. Do you get my point? So I will gift somebody in my family something and NPCI will know everything. That's the necessary anyway. So they had 3-4 crores of such transactions recorded in 3 weeks. This was pre-COVID data. And they want us to find out the distinction between one transaction comes, we need to build a system which will tell whether it's fraudulent or genuine. If it's fraudulent, there are certain very important numbers which can tell us. For example, a very new account opened just only a few weeks back transacts 50 lakh rupees. Suddenly. Then also we need to check what is the geographical location of that transaction. If that transaction is happening in some dense border areas like Chesapeake or Pokhara, then we have to alert the law enforcing agencies also, because might be the transaction is being done for terror funding. Issues are associated with that. So there was a team of NPCI who themselves sat and with their managerial skill, they labeled some transactions by themselves, and then they asked us to do the rest with the machine learning system. Okay, this is supervised learning. Unsupervised learning, nothing is said. You have to, the whole data is given to you, and you have to find the naturally occurring meaningful groups inside the data. And then, based on those groups, you need to interpret and understand the data, why it comes like this. This comes mostly as a form of, exploratory data analysis, where you know nothing about the data. And reinforcement learning is much like no human expert directly teaches you, life teaches you. Life is the harshest teacher, right? So the easiest example is there is a kid in a room, there is a candle flame burning, and there is a nice ping pong ball. So the kid is attracted to both of these, tries to touch that candle flame a few times, gets burned, cries, understands it's a dangerous thing, better to keep away from it. Spend more time with the ping pong ball. And plans his future activities like that. So there is an agent. This agent could be a small robot also, placed in some environment. The agent takes some action on the environment, moves 2 steps forward, 1 step backward, and so on. As a consequence of these actions that the agent performs, the agent receives some feedback. Based on the feedback, the agent performs its future activities. This strategy is used to make a robot team, we call RoboSwarm. Robotic swarm capable of coordinating cleaning of nuclear garbages from inside of a nuclear furnace. Okay? Radioactive garbages from a nuclear furnace where no human cleaner can go in. Right? Or maybe underwater rescue. So lots of such things are there. So these are the 3 facets of modern machine learning. And of course, I will not bore you with all these things. The biggest challenge is how to represent images most abstractly in terms of their abstract and higher level features. See, when I look at one of your faces or you look at my face, you don't see pixel lines. Top left corner 272, beside that 385. No. We immediately capture some abstract and higher level features. Nice mustache, cut mark on the chin, there is a mole, and so on. Right? Based on these features, we later on recognize the person even from group photo. Yes or no? Human beings are very good at that. Machines are not. When you look at 16 images, 8 from each class, Labradoodle versus KFC chicken, stare at them for 5 seconds, you know what is wrong. And not only that, you can explain. Nowadays, explainability is a very big issue for AI. Human beings can easily explain. What are the high-level features based on which you are distinguishing? Come on, 3 black dots, eyes and nose, right? For the Labradoodle. For this one, bar down or apple. Again, very tough data set for even for some neural networks, but very easy for human beings. The distance between the seeds of the apple, they are very close. 2 eyes are very far. There is a beach-like structure like nose, etc. etc. This one is toughest. So change from the cake versus Labradoodle. But first of all, there is no paper-like thing in the Labradoodle. Second, the eyes and nose are arranged on the vertices of a almost regular triangle, right? But cherries on cake are much higher. Now, how good it would be if we can have a machine learning system which would capture more abstract and higher level features in context to the classification purpose. So you see, the same entity, if you change the context of classification means this categorization, the features will change. I go to a bank, ask for a loan, the bank starts specifying me in terms of which numbers. Each of these numbers is a feature or trait or characteristics of which specifies me. The bank starts specifying me in terms of credit card, civil score, fixed deposit, annual salary, blah blah blah. If I go to a blood bank as a potential blood donor, those people will start specifying me in terms of whether I had thalassemia, what is my age, how much blood glucose I have, what is my blood pressure, and so on. Right? Same person, completely different set of features. Do you agree or not? So, this is the most important part, and this has been the central question in computer vision, video analytics, natural language processing, text mining, web mining, everywhere, speech engineering, signal processing, everywhere. The central question was how to represent one image, one text document, one speech signal, or one video in terms of most informative, distinguishing, and helpful features which at abstract and higher level means close to human beings interpretation features, based on which we can actually characterize these entities. And the answer in most appropriate manner of this time has been provided by the deep learning community. So in 2012, the deep convolutional neural networks, I have to again skip many slides. These are just So this is where deep learning comes. The deep neural networks, which are basically a very loose imitation of human brain, as people theoretically say. Deep neural networks are actually feed-forward, networked computing entities in a big network. These are very simple mathematically processing nodes, and they can take up the lowest recorded features like pixels of an image from an object, and then they go on combining these features in various linear and nonlinear way to give rise to context-aware higher level features. If the context is car versus non-car, the network will try to capture features like whether there are wheels, whether there is an engine pipe, whether there is a steering. If it is about bird versus non-bird, the network will try to capture whether there are feathers, beak, tail, etc. Do you get my point? So this automatic self-perpetuating representation learning is the biggest selling point of deep neural networks or deep learners. And there are a lot of deep learning systems like this one, which takes, this is extremely, it has a lot of applications in certain chains and so on. Most interesting part here is the generative AI. Generative AI systems are like this. You show it lots of pictures of certain entities, certain type of pictures, pictures of classrooms, pictures of human faces, and it can try to understand what is the, I told you, data is an instantiation of an underlying random process. So it can try to gauge the underlying spatial probability distribution of these entities. Once it gauges more or less approximately this random process, it becomes like God. It can sample from that random process and it can give rise to photorealistic artificial objects, which you never know whether it's fake or real. Nowadays, such deep generative models like the generative adversarial networks or diffusion models, which form the backbone of DALE. Have you used DALE? OpenAI's DALE? Yeah, some of you, right? GPT-4. So all of them have these generative models at their backbones. And you know, they can create wonderful, realistic text document, image, video, speech, voice, whatnot, which is certainly very dangerous as well. So this is just a illustration of how a generative neural network like GAN is arranging random noise pixels to form these handwritten digits. So it is reconstructing the handwritten digits of people which were not actually written by any people. So this is how the GAN images evolved with time. This person, 2014, was the birth year of generative deep models, the birth year of GAN. At that time, we didn't have the luxury of using NVIDIA different series, A, B, C, D, E, Q, etc. So, at that time, very poor images were formed. Now in 2018, this is from Big GAN project. If you look at this lady, her wrinkles, her gray hairs, every detail, the lady doesn't exist. This picture was never taken by a camera. Okay? This was synthesized by AI. And why so much detailed resolution? Because they are using industry level computing equipments like GPUs. Similarly, something has happened to this slide. All these images, and then came the famous CycleGAN paper in 2017 ICCD, which showed how you can transfer the style of one image into another, how you can convert the Yosemite National Park landscape from winter to summer and so on. And now it is possible to convert anything into anything. Prisma, lot of Facebook, AI apps, you must have seen people are synthesizing the photos of from Jesus Christ to Swami Vivekananda. Everyone's photos are being synthesized. All these are magics of CycleGAN like transition networks. What is happening? Yeah. Similarly, this you can convert maps into original sketches and so on. Or you can have an input expression and see how Mona Lisa looks like if she imitates your input expression. These are all in handheld devices right now. And the same thing happens in language modeling also. Although we have miles to go, I have a very separate and big talk on large language models, with which I don't want to bore you. But all of you who have used GPT, how many of you have used GPT? So few hands. I thought all of you might have used GPT. Or you are not telling because your teacher said. That might be one reason. But you know, with more and more power comes more and more responsibility. So the OpenAI has opened up a very big debate all over the world. Considering these large language models, they have been giving rise to huge possibilities and huge apprehension of loss of job in many perspectives. That's where prompt engineering is coming. In US now it's one of the highest paid jobs. What is prompt engineering? Design an intelligent prompt and give suitable instruction to the GPT about what you want to synthesize. Okay, GPT sometimes doesn't understand if the problem is described in a very wrong way. So one of my friends said, I copied a psalm of a monkey trying to climb oily bamboo, from Casey Nutt's famous book, and it gave me wrong response. Then I looked into the problem, and at that time I just wrote one article in Anandabazar Kolkata about GPT-4, ChatGPT, and some of my friends were attacking me. You have written about ChatGPT, cannot do Casey Nutt's sums. So I reformulated the sum. Okay. The first sentence was, what I remember is the first sentence was such that it was assuming that there are a lot of oil on the bamboo and the monkey cannot at all climb. So it gives infinity as a response. What time it will take to climb up, it gives infinity, which is wrong. So you need to put your sentences right. That is the prompt design. Okay. GPT has immense possibility, huge amount of bias, doesn't understand cultural idioms underlying our languages, should be adapted. This is a huge task lying ahead to adapt GPT for Indian regional languages. Lot of possibilities can open up. I have been talking with Google India regarding this adaptation part and so on. Now let me tell you, before I have about 12 minutes of time, so I switch to the other slide which I should take, about this venture of the TCG Crest. So, unfortunately, the scope of cutting-edge industry and technology in Kolkata is shrinking day by day. Some very few groups are contributing. Obviously, you know, many other speakers will enlighten you from Kolkata. And we are a few people who have to somehow live in Kolkata. And recently, one proposal came to Indian Statistical Institute. I am actually from there. And I took an academic leave after evaluating the weight of the proposal. Chatterjee Group, the Chatterjee Group, is a big company which is chaired by Dr. Poonendu Chatterjee. He's a very learned academic entrepreneur, I should say. He's from actually IIT Kharagpur and then California, Berkeley. He has a PhD from there, UC Berkeley. He's very aged now, around 74. I talked to him and I saw his vision is creating TIA for Life Institute in the eastern part of India. TIA for, have you heard of? It's a research institute in western India and very, very theoretical. On the other hand, Crest, which stands for Centers for Research in Education and Science and Technology. Research and Education in Science and Technology. So TCG Crest started to develop here since 2020, actually 19, but then COVID came. So the development happened since 2021 to 23. And by that time, it has earned a very good goal at certain measures. Okay? Crest is offering very interesting cutting-edge industrial level PhDs because TCG is a consortium of about 70 plus companies. In Kolkata, they have lots of in-house industrial projects and problems. Like they are starting the cancer research, lung cancer detection. They are working with, the there is a petro corridor for disseminating these petroleum-related products from the Haldia petrochemicals. Actually, Poonendu first started to mentor the Haldia petrochemicals. When it was much developed and was earning good revenue, the other companies also formed here. So TCG Group, under them they have TCG Life Sciences, TCG Digital, and many other companies which has lots of state-of-the-art industrial problems. Some of these problems are being solved in association with this not-for-profit research institute. And so the basic theme is to engage in translational research at the scale of cross-disciplinary areas, predicting in-depth understanding of science and technology, collaborating with leading Indian and global institutes. For example, there is a very serious talk going on forming the Rice University campus in Kolkata, co-located with TCG Crest. Rice University, you know, is a very good university, and the computer science department is very high level university. Okay? Just yesterday we had a long meeting with two representatives of the Mayo Clinic. Mayo Clinic is one of the state-of-the-art hospitals in the entire world in USA. They have a very advanced medical school. So we were talking about how to make Indian patient-specific data repositories and medical diagnostic systems, e-medicine, etc., much more realistic and original. And so these are the focuses. Currently, TCG Crest has 4 centers. We usually used to call them particles. The first director of TCG Crest, Professor Shobhushachi Bhattacharya, he was also the director of TIA for a long time. And before that, he was from Princeton University, he used to teach there. So these 4 verticals, actually envisaged by Professor Bhattacharya. First one is the Institute for Advancing Intelligence. This institute currently focuses on, obviously, artificial intelligence and machine learning, cryptology and computer security, and translational research in mathematics, or TREE, which holds certain mathematicians inside, and their objective is that their research won't be confined to just research papers or textbooks, but their research will translate into some marketable products, earning some revenues. So this is IEEE. I act as the Deputy Director of IEEE, in fact, so I am representing this one. Then we have CHIMTA, Center for High Impact Neurosciences and Translational Applications, which has a very state-of-the-art neuroscience laboratory, which goes on, from surgery of mouse to gathering the neural image, to staging of Alzheimer's, and they basically work on Alzheimer's and other neural disorders. We have Center for Quantum Engineering, Research and Education, or CQER, which is responsible for accelerating research in quantum computing and quantum engineering. They are trying to build up the first quantum computer here in Kolkata, and that has hit some headlines also. Then we have RISE, the Research Institute for Sustainable Energy. Current research areas, you can see the listing here: cryptology, artificial intelligence, financial analytics, batteries and supercapacitors, hydrogen energy, and so on. Recently, according to the Nature Index of India, TCG Crest has ranked 1 in physical sciences in the corporate sector. It has 125 plus papers published, 3 patents, 100 plus workshops. So for a 3 years journey, I believe that is quite commendable. TCG Crest is actively collaborating. So this is the enrollment of PhD scholars. We have total 57 PhD students right now. It is a very good platform which is admitting PhD scholars after master's degree through a pan-India examination like ISI, goes in the ISI model basically. And full fellowship is offered to the PhD scholars of the scale of what you get in IISc or IITs. And at the same time, TCG Crest offers 2 full foreign trips for conference attendance and paper presentation, okay, which gives, of course, I believe, PhD scholars who should go abroad to get more coverage, more acquaintances, and so on. So these are the collaborations and with other institutes. Definitely, ISI is in very big way involved here, although not explicitly listed. These are some of the companies which actively engage with TCG Crest: Matrix, Kilimanjaro, BART, DRDO, and so on. IEEE typically has, as I said, it has a lot of distinguishing features like cutting-edge self-funded educational environment, unique educational offering, and most interesting thing is, right from the PhD stage, students have an exposure to original industry level problems. So one of my earlier students, I end up with this story. My earlier student is not from here, from ISI. So he went to UK, and last year when I was traveling in Germany, that was in Munich, and he called me and he said, let's have a meeting. He was in Cambridge then. Then he told me, I'll just tell you how business opportunities emerge now. Very simple techniques, which not even include lots of AI. So he told me, I have opened up a startup inside Cambridge University, and our customer group are the health insurance providers all over UK. UK has a very nice health insurance system. You pay a hefty amount of money to the insurance agents, then for over the year, whatever happens to you, your doctor, your medicine, everything will be covered by that insurance provider. You get my point? Okay? Now these companies want to monitor their clients who are mostly above 40, 50, etc. They want to see if the client's lifestyle is good or bad. Bad lifestyle means a lot of alcohol, lot of junk foods, lot of McDonald's, burgers, and so on. And if that happens, and the clients, most of the death in UK happens because of cardiovascular disorders, okay? So So if the client's heart-related parameters are not okay, the company wants to build up a time series and issue regular warning to the client, hey, you are consuming too much of alcohol, we are not going to sponsor your heart attack. So, this sort of stuff they're trying to get. And the UK people, my student, Dr. his name is Dr. Kolkata, he discovered that UK people are very much fearful about putting, invasive procedures, putting a needle twice a week to take the blood and measure blood parameters. So what he said is, now it's a designation for him. What he said is, he devised a very simple mobile app. You will hold this mobile app before you will sit in peace, relax, put the mobile app put the mobile screen before your face, record a 30 seconds video 2 times a week, anonymize the video, send it through the app to the company. The company will calculate your cardiac output, systolic, diastolic pressures, and many other blood-related parameters. There are statistical formulas for doing that. First, from the 30 seconds color video taken off your face, how you're so. He was telling me, I devised this app and it's we are going to. Then I suggested how he can add some more machine learning features inside it. Now it's a product which is, they are trying to capture the entire Bangladesh market with this, and in India also. Some other companies are also there, which are coming up. But I am talking about this discussion about 1.5 years ago, right from now. How they are calculating the cardiac output from the image. Anyone has not worked with images here? Anybody who has some knowledge about video and image? From
the color image, when the blood pumps up, the redness of the face changes.
Right. So they are taking 3 intensity images: red, green, blue. And in the red image, the color intensity peaks are occurring the moment the heart is pumping fresh blood. So they are noting the interval between 2 such peaks, and from there they are predicting all this. And after that, there is some formula, some statistics for deriving the systolic, diastolic pressures. Then he visited India and went to this Apollo hospitals, Chennai and Kolkata. They tried to cross-validate with the original invasive procedures, and they saw very high, 85% or so match. So they are very boastful about that, and they are doing a good business. They are already sold into a lot of insurance companies. They are also very happy. The next step is to make a time series of each client and to predict what is going to happen to you after 4 years if you go on drinking in this rate. You get my point? This is where a simple idea of looking at the intensities of the red peak from a colored video translates into a marketable product. So many other ideas are there around the periphery, especially using the large language models and using the intrinsic computer vision techniques. CDOT approached us a few days back, and we, with another team from IIT Jodhpur, I'm just giving you some real-world examples. Do you know there was a horrible train accident in Odisha a few months back, right? So during the train accident, there were hundreds and hundreds of dead bodies whose faces were swelled, ruptured, full of blood stains and so on. So in that horrible situation, people are just taking pictures of these faces of the dead people and trying to match with the other database image or some other image. It's very hard to find a match. So we need some special feature extraction and deep learning procedures by which such deformed faces could be matched and the identity of the people could be retrieved. Now, Government of India through CDOT is their telecommunication company, they are trying to put it as a project for other disaster situations also, especially the deaths because of floods. You get my point? So there are widely huge opportunities. AI and ML are not shrinking the job market, they are creating new job markets. Our problem is we are sometimes very much misinformed. So you need to get the right information at the right place. Those who want to do some industry level PhD get acquired with this sort of real problems coming from industry for the good of the benefit of the society. 2 big issues are coming. One is sustainability. Next, when you are going to get mature, you are coming to our ages. 2 biggest problems. One is sustainability because of this huge population and demography. And the other one is climate. So Crest is going to open up, that is not here in these slides. Crest is going to open up along with the University of Oklahoma the Extreme Weather Prediction Center, which would be responsible for monitoring, along with Indian remote sensing agencies, the extreme weather conditions in Indian context. We are talking with Indian Remote Sensing, National Remote Sensing Society, I don't know, National Centers for Remote Sensing, NCRS. They already have a network for 3 lakh fishermen. They have 3 lakh fishermen in the eastern and western coasts joined with their network, and they are, by analyzing the oceanal currents and pictures, their satellite images, they are trying to predict which corner of the sea has more fish, besides issuing regular tornado and cyclone warnings. So, with the advent of machine learning, industrial projects have been trickling down for the benefit of all strata of our society. And I believe as youngsters like you have a very big role to contribute here. It opens up a lot of possibilities also. So with this I will stop. Thank you very much for your kind patience.
Thank you, sir. We are now open for question and answer session. We will be happy to receive any questions from the audience.
Yes.
As divided, the market of AI is moving. So how does it affect the market of data science?
These nomenclatures might be slightly confusing, but I would like to tell you, AI and data science have a very big overlap, and I don't really know what is data science. To me, statistics is data science. So these nomenclatures do not stand the test of time. I believe without data, AI systems cannot survive. And inside the core data science, database is also a part of data science, which is nothing new. It's a classical subject in computer science, okay, database management systems. So developments inside the classical database or relational database or data warehousing, data engineering, these have to have entangled growth with AI systems also. They kind of reinforce each other. There should be no problem in data science, what you are doing by data science. Only thing is people have to be updated. Okay. If you cannot catch up the trend, you have to, get completely wiped out. So the companies and the study, the study curricula need to regularly update them. There was a company which, when we were, you can see, when we were young, they used to manufacture photography films, Kodak. Kodak was a very popular company. Where is Kodak today? Because the entire photography thing changed. Everyone has this high resolution megapixel cameras in mobile phones. Kodak could not catch up with that trend, and it got completely liquidated. This is where it comes. Jobs are regularly there, like prompt engineering I just mentioned. Similarly, many other jobs are there which try to refine large language models or foundation models for specific purposes. Now people have to be aware of that, need to learn that slightly strategically, then they can compete and enter into these job markets. Right? Yes.
So in many IITs intake course, there is a particular course in industrial mathematics and computing. Is it related to data science or statistics?
Not much. Industrial mathematics and computing has mostly, I know the cryogenic and this industrial engineering department of IIT, the head was our very good friend, Professor Manoj Tiwari. They used to teach a whole circle of engineering mathematics, what you get in Greyval or Kreyszig, a bigger version of that, including many mathematical concepts which are very important, but maybe coming from cryogenic industry, mechanical industry, automobile industry, and so on. Okay, they are not specific to data science. As I said at the very beginning of my lecture, if you want to really do something in data science and artificial intelligence, two main subjects. One is linear algebra, in and out, and the other one is calculus of single and multiple variables. You must really learn all other things, Python coding, Jupyter Notebook, Anaconda, this, that, you can acquire on the go. But mathematics, you need dedicated time to learn. Otherwise, you understand nothing in actually in AI in really. What you will do, you will only just do some cosmetic changes in existing big software systems manufactured by company researchers like Google Brain or DeepMind and so on. And proportionately your salary will be also like that. If you really want to engage yourself in a big R&D, like Google India should actually engage in converting all their large language models into regional languages, and which they have started. If you want to engage in this sort of ventures, you need to understand these mathematical concepts. The interviews are also like that. Okay. So mathematics is the fundamental subject which you must actually. What happens to us? We like we gain mathematical skills after a lot of efforts and burning our midnight oils during 10th plus 2. And after that, 4 years or 3 years of bachelors, gradually the paradise is lost. We completely forget these mathematics. You don't have to do that. You need to retain your 10 plus 2 level skills and sharpen them if you want to really do something in AI. Okay.
It's the last question.
Yes.
Can you please move to the other audience also? Yes, other
He has some questions.
Yes.
Jobs. Replace what I don't
IT jobs which are
I would say there will be a lot of replacement, but the change of the nature of the job will definitely be there. That's why the age group in IT who are up to let's say 25, 28, etc., they have to kind of rephrase and replenish their skills. And I get regular, requests from a lot of companies like in this career fair. I went to one of my acquaintances from Wipro Data Science. Wipro has opened up a data science in Kolkata. I kind of trained them, those people. The person who is responsible for that. They have to upgrade themselves. So those people who studied their high school levels or graduate levels before 2012, 13, they are unaware of this. So they have to catch this level up quickly. And then, don't worry, I mean, this is not going to, what I say to him also, you need to catch up the changes. Maybe in next 5 years, quantum computers will be a reality. Quantum computers are even now reality. The problem is huge noise. We cannot get qubits stably. Okay, big array of qubits which are sufficient for machine learning purposes are not there. But if they become a reality, all the algorithms have to change. And then you will immediately see the emerge of post-quantum machine learning. Like now we have post-quantum cryptology. Okay, so you have to always sense the change in air and adapt yourself.